So do we have any questions in the audience or online? Up there. So to remind you, please introduce yourselves and say your affiliation, both for the people online and for the early career scientists to get to know the community. Thank you.
Thanks. Josh Cahill, APL. What wavelength UV are you using?
Oh, that's a good question. I knew somebody was going to ask me that, and I hadn't made a note of it. I'm sorry, I do apologize. And I chopped the slides out. But if you can find me afterwards, I'll give you my business card and we can talk about that, because it was very interesting. The anorthositic clasts do vary quite wildly, actually. I don't understand what that's been caused by, but perhaps you do. So thank you for the question.
I'll just go ahead and ask another question. What do you intend to do next with the sample?
Well, I have to talk to the owner carefully. Mahesh owns the sample. But yeah, I think we definitely would like to investigate the zircons with nanosims, perhaps, because it's the right sort of dimension. And yeah, I'm very interested to know what that bright phase is in the middle. I suspect I know what it is, but we won't know until we go in and have a look at it. So yeah.
Katie Joy, University of Manchester.
Oh, yeah.
Chip, I have a question for you.
Yes.
You showed that beautiful magnesian clast that you called a basalt at the end in the fine-grained plage matrix. It's very similar to a lot of the stuff Sam and I have been characterizing throughout the core section. So we should definitely have a chat, because we've got a couple of hypotheses, but extrusive basalt wasn't one of them. So it would be good to get your ideas why you think potentially it's a basalt versus other formation mechanisms.
Well, again, we only found that a week ago, and I kind of eliminated Amari basalt because it is fairly aluminous. But again, it seemed like the olivines were fairly high in nickel, in addition to being very magnesium rich. And the crystallization sequence that you see there is olivine followed by co-crystallization of olivine plus plagioclase. So, you know, it eliminates a number of possibilities, but, you know, another possibility that I think Brad Jolliffe had suggested on a similar lithology that he and his group found was some sort of magma related to a magnesium sweet rock. But I would really like to talk about this more.
Yeah, thanks, Chip. Katie's got a mic, but yeah, we'll chat about that. Yeah.
Yes. We follow the protocol. Bernard Fouin. So I have a question about ultraviolet that you mentioned. So do you mean ultraviolet spectroscopy or fluorescence under ultraviolet? And what do you learn from ultraviolet? UV. Yeah.
This is really interesting. I'm getting all the questions for the things that I left out, but it's really interesting. Well, we've just been experimenting because at the survey, we're mainly looking for minerals on Earth, and we use ultraviolet as a way of discovering things like scheelite, which is a tungsten mineral, and other examples. And of course, feldspar particularly responds nicely to UV, as you know, probably. And so we were just experimenting the other day. In fact, when Mahesh was visiting me, we went into a dark room and we suddenly realized that this whole sample was coming alive. And it's such a simple, basic technique. I love it, but I'd need to do more work on that. And thank you for the interest. It's really, it's got me excited, and I will follow up on that.
Okay, thank you.
Yeah.
Roman Tartes, University of Manchester. I've got one for Ryan. You stayed up late. Is there one thing you would do differently next time you process a core return from the moon?
Is there one thing? No. Build the stuff ahead of time. I mean, we were a little bit constrained. The way the money worked was, you know, we got the money and got the sample, and we had to start everything all at the same time. And having the gas extraction manifold ready to go, or at least farther along before, you know, we start that process would have made things go more quickly. Although it may not have mattered in the end because of the pandemic. But the same thing for the cold. We didn't talk about the cold sample processing that was part of ANCSA, but that we were trying to learn how to do while we were trying to do the PE, and that's not how you do it. And it was how we had to do it. We didn't choose to do it that way, but for Artemis, we will not do it that way. I'm sure there are other things.
Could I also kick in 2 cents also to this? Another thing that I think we should have done or could have done if we had, again, the instrumentation ready at the time, would be able to gather reflectance data before we did any extensive dissection. Because I think the reflectance data really helped identify in 73002 particular structures within the core that we would maybe have dissected the core slightly differently.
Yeah, no, that's fair.
Ryan, it's Katie again. I have a follow-up question. So for Artemis, for any core samples that are taken there, is there a plan to put a valve on the container, or would it be a similar thing where it's sealed on the moon and piercing tube required?
There is so much uncertainty around the tools that will be sent to the moon for Artemis right now that whether or not there is a sealed container on Artemis 3 is a bigger question than whether or not it has a valve. That's not to say it will or it won't. It's just, you know, times the clock's ticking. So it'll just come down to what's easier to do. Design something that's flight ready that can have a valve, or design a way to pierce it from the start and not have to leave it for the people who have to do it 10, 20, or 30 years from now. So there's not a straightforward answer to that yet, but we did learn that, and we would like there to be a valve. But if there's not time to get it done, is it better to send one without a valve than to not send one at all? Waiting for someone from headquarters to come in and mute me.
Well, Ryan, another issue tied to this in returning a sample and what sort of container you have is partially tied also to astronaut safety, because you don't want something to leak, particularly if you collected material from a cold trap that has volatiles associated with it, and you don't want it to be leaking into the crew vehicle and or the crew cabin, and therefore one has to worry about that safety issue too. That has nothing to do with preserving the sample, but simply astronaut safety.
Yeah, as they get to the later Artemis missions and they're able to go to the deep dark holes on the moon and the south pole of the moon, that becomes.
Thank you very much. We are running really late, so we have to cut this discussion and maybe take it over to the coffee break. I apologize, really. Thank you for staying with us this late.
Yep. Thank you, everybody.